Welcome to Orbs and Rods Mixed Method Study Part 4. We've had 3 previous presentations published in this series so far, and Part 4 really brings together some key aspects of the phenomenon recorded in the study over an extended period regarding these anomalous orbs and rods, specifically looking at form and movement. So again, I'd like to thank my fellow colleague, Dr. Brian Tyson, United States Department of Defense, for his ongoing collaboration in this endeavour, which has resulted in about 2 years of field-based research and probably coming up another 2 years of data analysis and interpretation now. So we're almost at the stage where we're going to write some peer-reviewed journal papers for submission in the very near future. So I'm really looking forward to that. But without any further ado, let's dive straight into this presentation and have a look at what we've got. So the background hasn't changed. It's still Karijini National Park, Pilbara, Western Australia, in the outback with a desert climate, hills, canyons, gorges, red rock, dirt and bush. The hypothesis itself, that hasn't changed. It's stayed like that for the whole study. So if a phenomenon can appear anywhere at any time, then it must transit the non-visible part of the electromagnetic spectrum because the human eye cannot observe it. The contents. So let's go through the contents of the presentation. So research questions stay the same, of course, as does the field methodology, the systems utilised in the sampling. So I won't spend too much time on that other than to just note it and summarise it, because in previous presentations 1, 2 and 3 you can have a look at that in more detail. In this study, key results revolve around object forms, and we look at UAP orb forms 1 to 4, UAP rod forms 1 to 4, and we also look at known animals recorded in the 850 nanometer IR spectrum at night, 1 to 4, and then reference that to nocturnal flyers of the Pilbara, Western Australia. We then dive into movement or characterising movement of UAP orbs and characterising movement of UAP rods, and then look specifically at comparing them to the movement of animals. After we've done that, we go into further discussion and interpretation, and we look at form comparison, movement comparison, and we take a look at synchronous movement, and then we look at intelligent control, the program so far, and moving forward with a funded program of research. So just in brief again, the research questions have stayed the same, from what are they and where do they come from, right through to what areas are they present in, and then in particular their appearances, how is it that we see them and don't, and that moves through to how they overcome inertia, gravity, and are able to demonstrate the characteristics of form and movement that we observe. If we look at field methodology, so these have stayed the same through the whole study, of course, and we've managed to standardise a protocol in the field that is reliable and repeatable by me or anyone else, and that was really important in terms of hypothesis-driven and field-based methodology that can be scrutinised and peer-reviewed. So I won't go through these in detail. The reader can check that out themselves. And then, of course, the systems utilised, these are the range of systems that could be applied. Now, in the study, we stuck with infrared, 850 nanometer infrared and electromagnetic measurements, and a little bit of looking at signatures and signal sourcing as well. We didn't have the full range of gear to do all of this. So we had to focus on certain aspects in terms of a mixed method study. And finally, before we get into the results, just a reminder about sampling, and the key thing to take away from this is that sampling was in cardinal directions for 1 minute, and both with 850 nanometer IR footage and electric and magnetic field readings that were also recorded at the site. Now that was done 6 times in an hour, moving around in a cardinal direction at 8 p.m. and then repeated it at different intervals overnight if there was an overnight sampling regime carried out as well. So that gave us reliable and repeatable data that could be analysed and statistical modelling applied to it as well. So without any further ado, let's get into the key results in this presentation 4 in the series and take the viewer through what we have found in terms of form and movement. So just starting off, I've got the summary slide here, which points out 4 common anomalous orb types for UAPs, 4 common anomalous rod types for UAPs, and 4 known animal types for UAPs as well. You will note over here that for orbs we had small grey speckled ones through to larger white ones. We then had larger white ones that were bisected, and we'll talk more about this in subsequent slides, but what appears to be some sort of a lateral extension around the spherical orb. And then we had here a slightly elongated one, and we could still see these bisected lateral extensions or rings around it. And if we move to rods, the first rod, we've got something similar here with these rings or lateral extensions around it. Now if you take a look at rod 2, they seem to be very symmetrical and almost spiraling around it in a rod, more like a spindle than a ring. And then we've got rod 3 and 4 here as variations on that, where you can see by the time we get to these larger rods, there's a bit more of an asymmetrical spiral around a long, narrow center rod. Now, if you compare that to known animal types, and you'll see this in the video footage subsequently, that we've got more of a wing-shaped, and here you can see 2 sets of wings. We'll look into that in more detail in subsequent slides. Here, 1 pair of larger wings, and in the video footage, you'll notice that we've tracked the up and down movement of the beating of wings that you just don't see in rods. And then we've got another one here that looks more like a dragonfly with 2 sets of wings, and finally another type of animal form or known animal form as well. So I'm going to take you through the 4 types of orb in more detail now. So if we look at the first one, these smaller grey speckled ones had this appearance here. It's almost like the surface of the sun in terms of, especially when you zoom in, that there's this constant swirling or movement, and these speckled extensions coming off it, or sort of shimmering. And you can see in the zoom here, when you do edge analysis and enhancement, that this looks sort of sun-like in terms of surface appearance as well. Now they move through very erratically through the field of view when filming, and in a very inconsistent direction unless they were transiting, because they would stop, investigate, appear to be investigating, and look around. But we'll talk more about movement shortly. We'll stick with form first. You can see in orb 2, these orbs were much larger and bright white in the infrared camera. And again, with edge analysis, you can see there was less swirling around on the surface, mainly because of the heat signature being so bright, and edge analysis was more difficult. We only really got the outside edge of the sphere as it transited through an enhancement or an enhanced view. You can see this wave-like undulating surface with more limited speckling or surface protrusions that you saw in a small grey sphere or orb as it moved through the view or the field of view. Now we can see when we get to the orb 3, this is where we still have a large spherical orb, but we can see it's bisected by what appears to be these rings. Now when you do edge analysis, you can pick them up in more detail and zoom in on them and see they're quite patterned there's not less swirling, and also there's no gap between these bisected rings and what appears to be the surface of the orb. They do appear, when they move at high velocity, to have some sort of distended view, and that may be just the camera operating at 30 frames per second, picking it up as it moves through the field of view. If we have a look at the fourth type of orb, we've definitely got some sort of extension or distended orb here, and again bisected by these rings. Now, it's not really a rod, because when this stops or hovers in position, it takes on a spherical orb shape. It's not maintaining this extended narrow rod between lateral extensions. Now, if you zoom in, you can see quite clearly these bisected lateral extensions on it, and when you zoom in, you can see there's no gap between it and the surface. And when we do zoom in and do close-up and edge analysis, there's a little bit of swirling going on in these bisected rings or lateral extensions that seem to surround the center of the sphere or the orb. And this transited in quite an arc skipping motion as well, and we'll see that when we look at the video footage a bit later in subsequent slides. Now, if we move on to rods, and these are interesting in and of themselves, we can see here now this is not a sphere that's been distended. This is a rod that maintains that center elongated structure in between it, but you can see again it's quite clearly bisected by these two rings here that appear to move or change position as it moves through the field of view at high speed or high velocity. And the enhancement's quite good on this. It really does pick up quite nicely using edge analysis the shape of these rings that seem to surround the rod. And when we go close up, we can see there's quite a waveform or layered waveform to these bisected rings around the center rod. And of course, here's a still of it moving through the area. So we've captured in video, 850 nanometer IR video, its movement quite nicely and broken down frame by frame. And I can show you later on the changing position of those rings as it moves through the field of view. Now, if you look at rod 2, again, this rod was quite a lot larger. The rod was a lot thicker and a very symmetrical spiraling around of this lateral extension. It's hard to tell here with edge analysis that it's actually more like a spindle. I have another much better view of edge analysis of a rod for that in a subsequent slide. But we can see here that it appears there is some sort of spiral or undulating lateral extension going around the center rod, and edge analysis and enhancement does pick this up. Again, the waveform is not quite as pronounced as in the previous slide with the two rings, and I've got a much better edge analysis that shows the spindle spiraling around a subsequent slide. Now, in rod 3, this was quite a good analysis or still and close-up and zoom of edge analysis. Because the image was a little bit dimmer, we were able to pick up the edge analysis through the whole form rather than just the outside edges, because of how bright the heat signature was in 850 nanometer IR. And you can see quite clearly here there is a definite spiral around a center rod, like a spindle that spins round and round and round, that appears to be attached to it with no gap between it and the rod. And in close up, we can see here how the edge of the rod, it seems to pass behind and in front of this elongated narrow rod in the center. Now, in form 4, this was quite a much longer, narrower and larger rod with more of an asymmetrical lateral extension around it. And when you zoom in, the edge analysis works really well, and we can see the spiraling that encompasses this long, narrow center rod. And when you zoom up, you can see that and how it moves behind and front and around it. So It's definitely not like a lateral extension in, say, a cuttlefish you'd find in the ocean. There's definitely a spiraling or spindle type form or function to whatever surrounds these rods that enables it to overcome inertia and gravity and demonstrate the movement or object movement characteristics that we observe in video footage. Now, the interesting thing was comparing this to animal forms or known animal forms in the Pilbara. We can't identify the specific species, but we can identify the morphology of these common animal types or nocturnal flyers in the Pilbara. And in this one, you can see there is definitely two sets of wings extending from some sort of center line body here. And close-up edge analysis shows the outline of these wings. This one's slightly blurred and out of focus, but we can definitely confirm that there is a known wing structure common to flyers or nocturnal flyers in the Pilbara. So in Form 2, this one moved through the field of view quite quickly, and later on you'll see with one set of wings that were moving or flapping up and down in quite a long narrow centre rod. Now we can't specifically identify what known species of nocturnal animal is, other than to suggest that it is a known species because of the characteristics you would see in form and function of a nocturnal flyer in the Pilbara, and edge analysis shows definitely that there is a centre body form there and one set of wings extending either side of it. Now if we move to animal 3, we can see here a lot smaller in the field of view, and when we zoom close up we can quite clearly make out two sets of wings here and a narrow centre body, which isn't straight, which almost suggests a tail and a head and even possibly some antenna there. And I suggest in a subsequent slide when we look at known animals in the Pilbara that are nocturnal what this might be. But again, definitely two sets of wings, and you'll see in film footage definitely moving in a way characteristic of known nocturnal flyers. And lastly here, another known animal form, a lot smaller in the field of view, and we can quite clearly see that there is some sort of tail structure to this body and a head structure with antenna, and in the zoom or the close-ups we can see this as well. Although we can't quite clearly identify the wing form, probably because of how it moves through the field of view, and you'll see that when we look at movement analysis. It's definitely a shape characteristic of known nocturnal flyers in the Pilbara. Now this slide again is what I referred to. We investigated what night flyers there are in the Pilbara, and there is the ghost moth that flies at night, and you can see here two sets of wings, a head, antenna, a thorax and narrow tail section. We have the leaf-nosed bat, again with one large set of wings flapping up and down, and then the centre body. And for example, we also have the barking owl, which is a night flyer. So there's a number of species, including a couple of species of locusts that are known to fly at night as well. And they're representative of the types of animal forms that you would film in 850 nanometer IR at night time that resemble or look like the images and the video footage that we've taken. And of course I've got some references or links to websites here where we looked at them. So we had the ghost moth, the leaf-nosed bat, the Goliath stick insect, a couple of species of locusts, the great green bush cricket as well, and the barking owl. So now I'd like to take the viewer through animal orb and rod movement and break down some frame by frame analysis and also look at video footage to show how we've debunked this and confirmed that we definitely have a number of forms of UAP that we've discovered that have no resemblance in terms of their form or movement characteristics to known nocturnal flyers in the site or location we were sampling in the Pilbara. So I took orb 2 movement. You can see in the video footage there, we've taken some selections and put them up there for you. And here we've just broken down a frame capture. Now 30 frames per second of this orb. Now it's not bisected by these rings, so you can see in frame capture analysis here a very consistent spherical shape moving through the field of view, slightly with a slight wobble or precession around it that gives us this sort of oblate spheroid shape, definitely uncharacteristic of any known species you'd find in the Pilbara, classified as some sort of nocturnal flyer or animal. Now these were erratic and could also move in any direction, as I said, with a wobble or precession. They could change direction abruptly with no evidence of acceleration, deceleration, or change in velocity. So moving at extreme speed. Now they also demonstrated object recognition and avoidance, including the observer and or the infrared camera when filming. Orb 3 movement. Now I've got a quarter speed here because it moved quite fast, and you can see its erratic movement through the field of view, and it's bisected by these 2 rings around this orb or spherical shape. And here we've got a frame capture analysis or sequence at 30 frames per second through 8 frames, showing how this is bisected, or the sphere is bisected by these 2 lateral extensions or rings that seem to spin around the orb or sphere with no gap between them. Now they could also be erratic and move in any direction, and it also demonstrated some sort of object recognition or avoidance, including the camera and observer. Object 4 movement. Now you can see here, if you look at this one quite nicely in terms of frame by frame capture and this arc skipping motion, we can see here that around it these bisected rings are moving in different positions. Here there's a kind of pause, which here you can see occurs about here in terms of arc skipping, and then it takes off again, and you can see the rings moving around it, and then it reaches this front-on view at the end of it too. So again, arc skip with extreme velocity in one direction here. So there wasn't this erratic movement around like I am doing with my red dot now. It demonstrated a definite move in one direction in an arc skipping type of movement, but not that you'd see, for example, in some film footage of animal forms. I'm going to show you where an insect will move like that, beating its wings. There's no wings evidence, although it's moving in an arc skipping motion. There is no evidence of wings used to fly and overcome gravity. They're not present at all. Right, if we look at rod movement, here's the one that's definitely not an orb. This is a consistent rod shape between what it seems to be 2 rings that are bisecting it and moving. So through the frame sequence, you can see here how the spiral or lateral extension or spindle that spins around seems to move through the orb as it moves through the field of view. Now what was interesting is that whereas it's clear in some of the other rods that there's definitely a spiral or spindle moving around, in this one it seemed to be more 2 rings similar to the bisected orb that we observed previously. So whether this is an intermediate or transitional shape or rod between a sphere and a rod, we're not sure of, but we do definitely know that it's in between being bisected by rings and having a spindle spiraling around it. Now in rod 3 you'll see it moving through a quarter speed because they move at very high speed, so I had to slow it down so you could even get a decent look at it moving through at full speed it's just a flash and it's gone, and we can't really break down what's going on. But the direction of movement's this way here to match the field of view. Now, as it came into the field of view, you can see how the spindle moves through in frame capture at 30 frames per second. Now this is 5 frames in sequence, and you can see here this section here is now moved through to this side here, and then that part has then moved through the front again. You can see the spindle starts again from the rear end, and you can see the symmetry is lost as we get out towards starting to get out of the frame of view, or the video capture mode, and it leaves the infrared spectrum of the camera. Again, these moved in a fairly straight line at extreme velocity, with the lateral extensional spindle appearing to spiral around at the center rod, perpendicular to the direction of movement. So rod 4 here, again following the camera direction from left to right, and frame capture analysis. A lot harder to determine which part of this has moved where, given the asymmetry in what appears to be the spindle or lateral extension spiraling around a very long narrow center rod. So this is quite a large one to look at when we were filming, very long and narrow. You can see it moves in an arc or a curve too, so it wasn't quite in a straight line. It really did move in a very wide arc through the field of view. Now we go to animals here. Now if you look at the animals, you can see what I was talking about this arc, that there's insects moving up and down in these curves, with the wings definitely beating 2 sets of wings, as you can see in this one. And we've got up here frame capture sequence. Although it's slightly out of view, you can make out the wings beating through edge analysis as it moved through the field of view. Now that's definitely a common nocturnal flyer of a known form, very unlike the UAP orbs and rods that we've filmed in the study. Now this one was interesting. It did move extremely fast, and we've got some video, a GIF file here that I put together, and you can see that the wings are beating up and down. And here we've got frame by frame analysis that we can definitely pick up the outline of one set of large wings that go from head to tail, not unlike the bat species common to the area that you'd expect to see. But again, the body doesn't quite look like a bat. So although it represents a known animal type in terms of form and function, it's very difficult to say what species that might actually be, other than it is atypical of the UAP orbs and rods that we've filmed and looks nothing like them. And lastly here, what we captured very nicely was the up and down movement of an insect with 2 sets of wings here, going from right to left, of course, and we can quite clearly make out how these wings are moving in frame by frame and beating up and down as it moves through the field of view, and edge analysis captures this quite nicely as well. Again, moving in an arc or a curve, and although some orbs and rods moved in arc skipping or curved motion up and down, the form and the shape of orbs and rods looks nothing like the functional morphology you'd find in known nocturnal flyers in the Pilbara. So I'd like to move to discussion and interpretation now, as we move through to the end of the analysis, and talk about what we think is going on in terms of form and function. So if we compare known organisms to orbs and rods, you can see here there's evidence that orbs and rods do not have features characteristic of nocturnal organisms capable of flight. So that includes the absence of wings of any type, the absence of a structure that moves like wings, the absence of features such as a head, antenna or tail, absence of other known anatomical features, and organisms that were known nocturnal flyers are observed in both the visible and infrared spectrum. Now, if you look at the orbs and rods, These have features that are uncharacteristic of any known organism. So rings or spindles that appear to rotate around a center structure. They're able to move with extreme velocity in the direction of movement. They can abruptly change direction without a change in velocity, acceleration or deceleration, and they're only visible in the 850 nanometer IR spectrum when filming. Now, if we do an overall movement comparison, and I've got some GIF files here that show it quite nicely when we put them all next to each other, we can see that orbs are often erratic in any direction: stop, pause, reverse, investigate, and demonstrate obstacle recognition and avoidance. Rods, you can see them move in a straight line or a shallow curve in one direction, but they can turn sharply and demonstrate obstacle recognition and avoidance. They have rings or spindles that move around a center piece or rod. Now, organisms, they are often filmed, nocturnal flyers were often filmed moving in arcs or curved in one direction, turning slowly with wings extended, beating and moving up and down. Now, another very interesting point about rods is demonstration of synchronous movement relative to each other. Now, if you look in the GIF files I've got here in the video footage, you can see that we had rods moving parallel to each other, and you can see them there. There's two that we caught. And then if you look down here, we can see that they follow each other in groups through the field of view. So we've got three moving through here together, following each other. And we also had rods trailing each other as they negotiated obstacles through the field of view, which we've got in this GIF file down here. Now, to us, this suggests an awareness of their surrounding environment and of each other. And I think it's in presentation 2 where we talk about the signal that we picked up and how we think that might be correlated to their orientation to their environment. And we looked at some animal analogues that use electric field strength and magnetic field strength to negotiate their environment in the physical dimension. Now, we've used this slide before, but we come back to intelligent control because what we've got here, the evidence so far, does suggest some form of intelligent control is going on, and that orbs and rods are under intelligent control. It's not known whether they are man-made, natural, or of non-human origin, though, but we do know the way they harness or utilize energy in terms of form and function and negotiate the physical dimension is unique and is uncharacteristic of known nocturnal flyers that we've seen in the Pilbara. So just a little bit more on intelligent control. So the evidence that we've come up with that suggests intelligent control is synchronous movement, so able to orientate themselves to each other, object avoidance, so orbs and rods avoid objects and change direction, object interaction, so orbs appear to inspect or investigate other objects. And then we've also got observer and or the camera recognition. So orbs appear to change direction in response to being filmed or when transiting the field of view. So the program so far, we're nearly at the end now. So we've got 4 presentations on the program of research now published on ResearchGate, and the narrated versions are published on the YouTube channel that go with it, including this one. So that leaves us with Phenomena Mixed Method Study Part 1, Orbs and Rods, Phenomena Mixed Method Study Part 2, Interdimensional Anomaly, Phenomena Mixed Method Study Part 3, Field Repulsion Technology, and this one, Phenomena Mixed Method Study Part 4, the present study. Now, what we've also started doing is 3 peer-reviewed papers in preparation for journal submission. We have a book on the science of UAP in review or production with publishers at the moment, so that's a work in progress. An author autobiography is about to be launched as well. We now have an extensive archive of catalogue data collected over 2 years of fieldwork, and we also have research and business cases prepared and made available as well. And just to wrap it all up, in terms of research and technology development or technology transfer, we're looking for a long-term funded sustainable program which will help us determine the origin of orbs and rods and what they are, determine their energy source and how it is harnessed or used, determine the nature of an associated interdimensional anomaly. We're looking at developing phased array technology to interact with the phenomenon of orbs and rods. We want to develop applications in industry, defence and space, and we've got some ideas and concepts there that we're thinking about. And develop and roll out an undergraduate, graduate UAP program in the tertiary education sector. Now I think this is really pivotal or key, is to link up industry with public tertiary education in the private sector through such a program, and having a book, 3 published journal papers and 4 presentations, I think gives a lot of kudos to that concept and enables an undergraduate graduate program to be launched underpinned by all that, because we already have a lecture series done that we can base papers on, and a book that we can use as part of that as well. So I'm in discussions with a few people about that. So that wraps up presentation 4, and I'd really again like to thank Dr. Brian Tyson for his ongoing facilitation of this whole program over 3 or 4 years now, including all the field research, the analysis, the results, the presentations between his peers in the Department of Defense, United States Department of Defense, and myself in Australia. So it's quite a collaboration between Australia and the United States in terms of its potential implications for energy and for defence and science, industry, defence, science and technology into the future. So I hope you enjoyed the presentation, and we look forward to future endeavours in this whole area of UAPs.